Okay, so please open your review problems because I don't want to copy the problems. Okay. So, oh, sorry, where is the problem? Okay. Sorry. Okay. The test one or the midterm one includes two parts. So the first part is about the linear algebra. The second part is about the differential equation. So for the linear algebra part, so the first point is how to solve linear system and how to find the determinant or determinant. Third, how to find, sorry, how to find eigenvector and eigenvalues. And fourth, I don't know what happened to my pen. Four, how to determine linearly independent or linear independence or dependence, and how to write them as a linear combination. How to write them as a linear combination. Okay, so let's first look at the first part. I'll show you the problems in the worksheet, and then I will summarize the second part. Okay, so let's look at the problem one. So if you look at the problem one, so the problem one is like this. So I will not repeat it from the problem, you know. So you write it as a, okay, you don't have to write it as a matrix, but if I do it, I will write it as a matrix. Okay, that's fine. So if you look at this formula, okay, I just repeat x1 plus 3x3 3x5 plus x6 is 0. This is the first one. The second one is x2 plus minus 4 x3 plus 8 x5 minus 13 is 0. x4 minus 2 x5 plus 16, 17. So you can say this is echelon form, right? You don't have to do the Gaussian elimination, right? Okay, means this, I don't think this kind of problem will be in the test. Maybe in the test, the problem will be a general equation. You have to first do the Gaussian elimination and then convert that matrix in this form. And then, of course, you have to know how to write the solution if the equation like this. So the first one, from this equation, you can read this is leading term, right? This is x1, x2, x4. Okay, if you write it in matrix form, this should be 1, 0, 3, 0, 1, 1, right? This is 0, 1, 4, 0, 8, negative 13, and 0, 0, 0, 1, negative 2, 17, like this. You can say leading term, right? We have this is leading term, and the free variable, the rest of ones are free variables. This is x3, x5, x6. So I think the method, maybe you already know this, the method is fixed. You keep all the free variable in the right hand side. Okay, you can say, okay, free variable, this is free variable, free variable, free variable, free variable. You put it in the left hand side. This is x1, x2, x3, x4, x5, x6. Okay, and then you put this in right hand side. So you write in, okay, this is, oh, should be slow. Okay, negative 3x3 minus x5 minus x6, and then this is 4x3 minus 8 x5 plus 13 x6. No, this is x2, right? x3. What's x3? x3 is just x3, right? And then x4 is 2x5 minus 17 x6. What's x5? x5 is free variable, just x5. x6, because x6 is also free variable, that's x6. So that's a solution, but our the final, you cannot leave the final answer like this. If you leave like this, I think you will lose half of your score. So you have to write it in a vector form. How? You assume this is R, S, T, like this, and plug it back. Okay. So you see it. X3 is R, S, T, like this, and then you write in a vector form. For example, you put all x3 together. You know what's it's, for example. Okay, if you didn't set x3 equals r, you can just write in x3. Okay, I just write x3 and in this form, and plus x5 in this form, plus x6 in this form. After you reset it, this is R, this is S, this is T. But they're the same. Okay, you can keep this, just say x3, x5, x6 is free variable. But you can also use RST. Doesn't matter, but if you write RST, you have to say RST is in R. You have to write this. Tell me RS is parameter. Okay, so you just keep this is -3, -5. This is 1 because put it is outside. This is 0. This is 0. So x5, -1, -8, 0 because there is no -5. 2. Just read the coefficient directly. 0, 1, 0, and let's look at x6. -1, 13. No x6, -17, 0, 1. Okay, so you have to write the solution like this: x1, x2, x3, x4, x5, x6. As we write, this is v1, v2, v3. Okay, I just don't want to copy it. rv1 plus s v2 and RST v3. Okay, put this here, this vector here, this here, and RST is in R. Okay, so that's the first problem. Okay, maybe in a test, the problem will unlike this. Okay. So, and then let's look at the problem. So this problem is kind of ask us how to solve linear equation. Linear, okay, questions?
Yeah, quick question. We can write it out as a matrix still, right? In the final answer?
In matrix?
Like, not like as the individual, like, instead of like specifically saying this is V1, we could just write out the like V1. Like
yeah, you can write it in this.
Okay, thank you.
Yeah. I'm lazy. Otherwise I have to copy it again. Okay. I joined the meeting. Okay. That's fine. Okay. So this problem is kind of tell us how to solve a linear equation in very special form, because this is echelon form. Because I don't know the problems in the midterm exam. Perhaps the problem will be unlike this. Okay, so let's look at one problem. So for example, the problem 3, I will not follow the order, because I was trying to summarize the similar problem. So, and then let's look at the problem 3. Okay, the problem is like this is elective 2x minus x2 plus 5x4 is 1. This is, okay, sorry. 2x1 plus x3 plus x4 is 3. The first step is write out the augmented matrix. This is negative 2, negative 1, 0, 5, 1. This is 2, 0, 1, 1, 3. Write out the augmented matrix. Okay, the first step, if you don't know how to compute in the test, try to write the details, because if you write it in this form, the grader will give you some partial credit. Okay. So that's the first step. And then the step 2 is convert in the matrix, the augmented matrix, into RREF. Okay, I think, when you are doing this process, you have to write the details. Okay, this is, okay, so let me continue this, because otherwise I have to repeat it again. So first, let's cancel this place. How? So, okay, in the book, okay, the first you convert this into 1. So you multiply half R2. Okay, I will not follow because the method is not the same. For example, I will do it in this form. Okay, the first, let's cancel this number. Copy the first one and cancel plus R1 to R2. Add R1 to R2. So we get 0, negative 1, 1, and you plus, we get 6. You plus, you get 4. And then multiply by half, negative half into first row. We get, we didn't change this. We just copy like this. And then we get 1. We get half. We get 0. We get 5 over 2. We get a half. So, and then our goal is what? We make this to be 1, 1. Okay. How? We can multiply by 1, negative 1 in R2. So we get 1 half, 0. We just copy that. We didn't change anything. We get 0, 1, negative 1, negative 6, negative 4. I'm right. This is not a, RREF, because this is non-zero. It's half. You have to cancel this. How? You multiply negative half. Okay. In R2 and add it to R1. So you try to cancel it because we didn't change the second one. Sorry. 1 half like this, like this. So, and then we try to cancel this place. This is 0. That's our goal. You multiply by negative half, you get a half. You multiply negative half, you get half, right? So you multiply by negative half, you get 3/2. So you can say now this form is kind of the problem one, right? It's kind of the problem one. From this, you read the x1, x2 are leading term or leading variables. Anyway, leading variables or leading term. The x, okay, sorry, I forgot this. Okay, so x3, x4 are free variables. Okay, the goal is the same. I just repeat it again. You write this form. Okay, something talking to me. I think it's better to write this. Why? Of course, I might do the problem, I might not, because I'm very familiar with this part. Because maybe you made a mistake. If you write this part, the grader will give you some partial score. Okay. Okay. So let's first write this. So you can just write this directly. You get x1 and x2, x3, x4. So this is the vector. You can say the x1 is negative half x3, negative half x5, no, 3, 4. And the second one is this plus 6, x5 or x4, x3. This is free variable. You don't have to think. This is just x3. This is x4, and then plus this one. This is negative 4, 0, 0. And then the method is the same. You write in x3 and x4 and plus this one. Okay, you may say for this problem we have an extra one because this is non-homogeneous equation, right? That's why. Okay, so we just copy this. You cannot change this one. It's always the same. And then how do we write this out? This is negative half. And then 1, just copy the coefficient. Don't think, you just copy the coefficient. Okay, 1, 0, and half, 6, 0, 1. And then you write this, you set this is R, you set this is S. Or you can write in English, set R is x3, S is x4, and then you write in this form, copy this in this place, plus S, copy this into this place, plus a vector, copy this vector to this place, and remark RS is in R. Okay. So it's kind of, I think for the problem 1 or problem 3, there should be a problem like this. Okay. Maybe the combined, I think there should be only one problem to solve the equation. Okay. So, and then, so I will, for this problem, it's kind of the method is the same. For the first problem, it's just ask you how to find the solution if you already use the Gaussian elimination. But the second problem is, the problem 3 is to first use the Gaussian elimination, Gauss or Jordan elimination. Okay, Gauss-Jordan elimination, and you convert it into RREF, and then you read from the RREF form, matrix form, you read the solution or get the, in general for me, I can read the solution, directly. You read the solution and write it as in the vector form. Like I said, if I think the problem will ask you write it in vector forms. If you didn't write this form, you will lose some score or some credits. Okay, just keep this, be careful and pay more attention to the requirement. Okay. You know how to blah blah, you lose the credits, it's unfair. Okay. Okay. So, and then for this, for example, for this kind of two problem, you can say the solution is non-unique, means that you have many solutions, right? But we know for some case, the solution is unique. So it's kind of, there is a theorem says if ax equals b, determinant of a is non-zero. For this case, x is the invertible of b, right? So for this kind of problem, there is a Kramer rule. I think there should be a problem like this. Use the Kramer rule to solve equation. You may say, solve equation. You may say, I already know the Gaussian elimination. Why do we have to study the Kramer rule? Because for the Kramer rule, you can get the, the solution. It's kind of, by a formula. That's more directly. Okay. So the problem should be like the, okay. Okay, for this, first you have to know how to find how to solve the invertible, the inverse of the matrix. The first one is about the inverse of a matrix. Okay, the first one, if the matrix is 2 by 2, okay, is A, B, C, D. We write this is A, and the determinant of A is non-zero. This is the assumption. Okay, if it's zero, we will not ask you to compute this. Okay, so you have to memorize the 2 by 2 matrix. The inverse of 2 by 2 matrix is determinant of A and 1. And how to write this? This should be like switch the order of D and A and keep the CD position and add a minus. So just remember this. And also why? Because it's also important for other subjects in the future. You may meet, anyway, just very important. So, but okay, for this you have to memorize this. Why we assume determinant is non-zero? Because you can say determinant is in the position of denominator, right? This is only 2 by 2 case, but this method cannot be used in 3 by 3. So for 3 by 3, there is a standard method. I think there should be a problem like this. Okay, for example, if you have a 3 by 3, so for example, 3 by 3 or 4 by 4 or n by n, the method is the same. Why we emphasize the 2 by 2? Because it's easy. You can get the answer directly. You don't have to do the following stuff. So first, this is A11, this is A22, A12, A13, A21, A22, A33. No, sorry, A23, A31, A32, A33. So this is A. How do we? So the method is how do we find the A inverse? The method is fixed. So you write it in. So let's look at the problems. Okay, where is the problem? Okay, I think it's, wait, where is the problem? Okay, so yeah, problem 13, like this problem. This is 1, 1, sorry, 1, 2, 2, 1, -2, -3, and 1, -3. You first, you add identity matrix here. If this is 4 by 4, you just add a 4 by 4 identity matrix. You use your RREF, convert this side to identity, and if you do the same operation for the right hand matrix, you will get a matrix B, and this B should be the inverse of A. It's kind of use a Gauss-Jordan elimination like this, or Gaussian elimination. Okay. Anyway, so let's look at this problem. How? So let's look at. It's very complex. Its computation is very boring. So you first cancel this number and this number. How? So negative 2 R1 plus R2 R1 2 R2 plus R3, and then you can say copy 1 1 1 0 0, and then it's kind of you get this. This is 0. That's your goal, right? You get 0. Am I right? I think I'm right. Right? And then negative 1, right? And negative 2, 1 0, and 0 1, negative 1 2 0 1. So that's the first step. So let's erase this part. Okay, and then so you cannot switch the columns. You can only do the row operations. Okay, don't ask me why now. You have to. This is only you cannot change the columns. Okay, so what happened to my pen? Okay, so and then let's do the second step. So the second step is, I think I'm right. So and then this is 1, right? You have to switch, make this place is 1. Why? This place is Y. What you cannot, switch second column and third column because that's forbidden. You cannot do that part. You can only do the row operation. Okay, so now switch R2, R3, or you can write it in this form. That's fine. Okay, so 1 1 1 1 0 0. So switch 1 1 negative 1 2 0 1 0 0 negative 1 negative 2 1 0. I may made a mistake. I'm not sure now. Okay, so next step is you have to make this is 1. So R3 like this, or you write this form. It's the same. Okay, just unload it. 1 1 1 1 0 0 0 1 negative 1 2 0 1. So 0 0 1 2 negative 1 0. So what's the next step? Okay, cancel this number. How? So negative, no, R3 plus R2, no, add R3 into R2, or negative R3 plus R2. So let's first copy because you didn't change this. 0 0 1 2 negative 1 0. So your goal is to cancel this place. 0, you will not affect this place. 1 0, just add them together. You get a 4 negative 1 1. So it's kind of negative R3 add to this. It's equivalent to R1 minus R3, right? You get 0. Oh no, 1 1 0 negative 1 1 0. So like what I said, B is the inverse of A. So that's a matrix. I may make a mistake. I don't know. I think where I made a mistake. Anyway, that's fine, but the method is right. Anyway, you just repeat what I do, by yourself. Okay. So this is, I think there should be a problem like this. I don't think the matrix will be 4 by 4. It's, If it's 4 by 4, we only have 1 hour. You don't have enough time to finish the problems. Okay, no worry about it. Okay. Anyway, I'm not sure where I made a mistake. Anyway, that's fine. Anyway, I think I made a mistake somewhere. Okay, let me double check. So 1 1 2 0 1 1 1 like this. 1 1. Oh, I'm not finished. Sorry, I'm not finished. So the next step you have to, sorry, but nobody tells me. Okay, if I made a mistake, please tell me. So you have to cancel this place. I'm not finished. Okay. Sorry, I forgot. So this is negative R2 plus R1. Okay, you continue this. Like, oh, I'm right. Now I'm right. So you get this is 5, and then you get, so because I don't have space, I write it in this form. Okay. This is 1, 0, 1, 2, negative 1, 0, and 0, 1, 0, 4, negative 1, 4, 1. We get this is 1, 0, 0 minus this is 5 and 2. Okay, hey, I'm right. So this should be the final solution. This is A inverse. Okay. So this is about how to find the, how to find the inverse of a matrix. Okay. So, and then this is kind of one problem, but I think there is also one problem to, one problem about write the Kramer rule. Okay. So first, okay, so let's look at the problem about the Kramer rule. I think the problem, where? Okay, let's look at the problem 14. So if you look at the problem, so the problem, I have to copy this problem. It's so annoying. Okay, so I will not copy the equations. Okay, it's in page 10. So I will write the matrix form directly. So the first one is 0, 0, negative 1, 5, yeah, 7, 0, negative 2, 4, 1, 9. So if you have any question, just type it in the chat box. Okay, 0, 2, negative 1, negative 1, 17, 1, 1, 1, 1, 14. So this is kind of the augmented matrix. So for example, this problem is asking you to write, for example, you write the solution in x1, x2, x3, x4. So the problem is asking you to use the Kramer rule, write the x3 component directly. So if a problem asks you to write the solution in the by the Kramer rule, means that when the author is giving the problem, he already know the determinant of this part is non-zero. Otherwise, this problem is wrong. Okay. So, for example, I will not write the R3 because X3. I will write the X1 because you already know the answer, but the methods are the same. For example, I just write X2. No. X2. How? So the denominator, or you use the observer value is 0, 0, negative 1, 5, 0, negative 2, 4, 1, 0, 2, negative 1, negative 1, 1, 1, 1, 1. So it's kind of the denominator is always the matrix. You write A, X, B, So it's kind of the determinant of A like this. So what's the numerator? So it's the determinant of what? So this is x2, means that you replace the second column by the right hand side vector. So you just write 0, 0, 0, 1. So replace this one by this one. 6, 9, 17, 14, -1, 4, -1, 1, 5, 1, -1, 1. Clear? So if the you don't know which component the professor will ask you in the test. So it's but if the problem is asking you to write the x1 component, the numerator, no, the denominator is the same. You just replace the first column by the right hand side of vector. Okay, is the arrangement is 3 by 3? Oh, no. Yeah. Yeah, okay, that's fine. Anyway. Okay, so this is about the Kramer rule. Maybe the problem in the test is 3 by 3. Then I cannot imagine if it's 3 by 3, ask you to write the x1, x2, x3. Too much work. Anyway, I don't think the instructor will ask you in that form. So, but in the 2 by 2 case, if it's 2 by 2 matrix like this, AX is equal to B. So if the problem is like this, is 2 by 2, you just write this. Okay, and then you write A, B, C, D. The inverse is 1 over determinant of A. For this case, the determinant of A is A, D minus B, C. It's non-zero. And then write this is D, A, -3, -D, and -B. And then you put this matrix here, and then you know what's B, what's A, and then you get the answer directly. Clear? Okay. So about this part, one more problem. Like here, we have to know how to compute the determinant. It's possible the instructor give you a problem, ask you to compute the determinant. Okay, so the problem, I think, in general problem, the matrix were not very big. The size, I think at most of 4 by 4. Anyway, or 5 by 5. It cannot be 100 by 100. Anyway, so how to? I think I forgot to write it in this part. Okay. Oh, yeah. I didn't explain this part. How to find the determinant? Okay. The determinant. So for 2 by 2, I think you already know it. But for 3 by 3, sometimes it's complicated, right? So let's look. Okay, so let's look at one problem. The problem 12. Okay, this is 7, 7, 7, -7. This is 1, 0, 0, 1. This is 0, 3, 1, 1, -1. No, -2, 1, -2, 1. Find the determinant. Okay, so we know you have to expand the determinant in a smaller size. So I think that's the definition, kind of one of the definition. But we already know many properties of the determinant. For example, you can just add one row to another row, but it doesn't change the the determinant, right? So for example, how do we find the determinant? For example, we can expand in second column or the third no, the second row or the second column, right? Or you can, if, for example, if you expand by second column, or second row or the third column, you can say both have at least three, at least two non-zero numbers, means that you will get two, determinants of 3 by 3 matrix. But it's complicated, right? Why don't just cancel one number? For example, in the solution, the professor cancel this number. I will not follow that way because the method is non-unique. Okay, it's not unique. So how? For example, I want to cancel this number. Nobody knows which one will be easier. Okay, so for example, let's cancel this. So how do we cancel this? We multiply by -1 in the first column and add it to the first one. No, add it to in first column. We just copy this. 7 7 0 1 1 0 3 1 -2. No, 1 -2. So we get this -1 added to this one, or you subtract the first column from the fourth column. So we get this 0 1 3, and then we can expand in second column, second row. So we get, this is like, I think I taught this in the class. This is A2 1, right? Means that the coefficient is -1, 2 plus 1 is 2 plus 1 is 3. I just write the answer directly. And then 1 multiplied by 1. Cancel this and this. So, okay. Kill this and this. So 7 7 -14 3 0 1 1 -2 3. Okay. And then, okay, we got a 3 by 3. So this is equal. Sorry, this is equal. Okay, this is equal. Because you add one column to another column or add one row to another row, you didn't change the determinant. Okay, and then, so it's the same. How do we do? So for example, there is a 0. We like zeros. Okay, so we can multiply by, for example, we can, for the third column, you multiply by 1. Okay. Third column, you multiply by -3 added to the 1. So this is -1. And then this is, we copy this. This is 1, 3. We keep this 0, -3. So multiply by 3. So multiply by -3. Okay. So we get 42, right? 0, -3, 10. And then we get 1. So this place is A23. So A23, you keep this negative, you get a -2 plus 3 and 1 and multiply by. So now you kill second column and second row and third column. So you get this, and then you get an answer directly. Clear? I'm not sure. I think the method is this, 94. I think the answer should be right. Anyways, that's fine. I'm not. I only care about the method. I don't care about this, the final answer, because in the test, the problem will be not like this. Okay, even though in the test you made a mistake. For example, your final answer is, it's just not right. But you write the whole process, you will get almost all score. Clear? Okay, just write more details. You don't have to be, focused on the final answer. The process, the procedure is, I think, is more important than the final answer. In general, if you made a mistake on the final answer, you just lose one or two. Okay. Okay. I'm not sure if I made a mistake. Maybe I'm wrong. Anyway, that's fine. I think it's right. It should be right. I just didn't get the final answer. So
I think there's just a negative sign. The one that you multiplied at the end, isn't that negative?
here, this is negative, this is positive.
Okay.
Yeah, okay. The whole is positive. Negative, negative, positive. I think, okay, just get an answer. This should be 19A plus. I think it's wrong, right? Anyway, that's fine. I'm not sure. Okay. So let's erase the final answer. Okay. So I think this is all about the linear algebra. Okay. Oh, sorry, I forgot one. I think the most important one is the eigenvalue. Okay. So about the eigenvalues and the eigenvectors. So about the eigenvalue, so the first, if you have matrices, so if the problem is asking you to compute the eigenvalue, okay, so the problem in general should be like this. So if the problem is already giving you the eigenvalue, okay. Our goal is to find the eigenvalue and the eigenvector. If the problem already give you the eigenvalue, for example, is 3 by 3 matrix, you already know lambda 1, lambda 2, lambda 3. So how do we find the eigenvectors? So you compute lambda 1 I, and then you solve alpha I. That's the eigenvector associated with the lambda 1. You compute lambda 2 I x2, 0, 0. You get alpha 2. This is the eigenvector associated with the lambda 2. And the same method, x is 0, you get alpha 3. But perhaps in the test, you don't know the eigenvalue because the instructor, the professor doesn't give you that. You have to compute it. How do we compute it? So you have to know how to compute the eigenvector. I will not repeat this part because I already tell you how to solve the linear equation, right? This is linear equation. Okay, this is the first linear equation. This is the second. No, this is the first linear system. This is the third one, second one, third one. I didn't say you put them together as a linear system. Clear? Totally solve them independently. Okay. Eigenvectors. Oh, eigenvalues. So how you first compute this? This is the determinant of A minus lambda A. You will get a polynomial. It's called polynomial. Okay, polynomial. It is called characteristic polynomial, but you don't have to care about the name now. Just compute this. This is step 1, and then the step 2 is set it as 0, and then try to solve lambda 1, lambda 2, lambda 3. Okay, of course, now we are dealing with 3 by 3 matrix. If the problem is given to a matrix of 2 by 2 or 3 by 3 or 4 by 4, you should solve 4 eigenvalues. I don't know which problem will be in the test. Okay. So I will not repeat this part, okay, because the whole process I already know. Okay, the problem is quite hard for this part if, the equation, the polynomial is very complicated. You cannot solve lambda 1, lambda 2. Sorry, that part I cannot help you because you should know that part in your high school. Anyway. Okay. And then the final linear algebra problem, I think, is about the linear combination or linear independent. Linearly independent. Okay, the problem should be like this. So the problem may ask you, judge if the following vectors are linear independent or linear independent. If it is linear dependent, please find the linear combination of them. So in general, I think the problem should be linear independent. No, linear dependent. Because if it is linear dependent, they can ask you the second problem, write out the linear combination. Clear? So so in general, for example, look at the problem 18. So maybe you may ask me, but if it is linear independent, how do we know it is linear independent? Okay, I'll tell you here. So the problem is that, okay, how do we know these vectors are linear independent or not? So for example, let's look at the problem of this. So this is the first vector. So the second vector is like this. The third one is 10, 11, like this. So step one. So how do we know they are linear independent? We know we can write this is V1, this is V2, this is V3. So and then we write X1, 1, 2, 3. Okay, I will just copy it. Write it. Plus X3 and 10, 11, 12, and solve this equation. So you might ask me, why do we do this? The problem is that if we write it in this form, we can, what we do, we can write it as a matrix here. So we can write it in x1, x2, x3, and then, so we write this. This is 1, 2, 3, 5, 6, 7, what's this? 10, 11, 12, and this is 0. So we know, so if we know if the vector are linear independent, if and only if this equation has trivial solution, means that only have 0 solution. So means that, so if it is linear independent, means that this system only has 0 solution, means that the determinant of A is non-zero. Cool. So if the determinant of A is 0, means that it's linearly independent. This means that linearly dependent, sorry, linearly independent. Okay. 0 means you have many solutions linearly independent. So you may say, okay, do I have to first do this? So if the problem already, okay, if the problem only asks you to say if these vectors are linearly dependent or independent, you can use this method because you just compute the determinant. It's quite simple, right? And very easy. But you can, if the problem already asks you to say if it is linear independent, please find the linear combination. You use that method. Okay, if the first case happen, it's fine. This method is fine. But if the second case happened, you use this method, no, it doesn't work. Because by this method, you cannot get the linear combination. You have to use the method in the answer key. Okay, so you try to solve this equation. It means that so the problem is equivalent to find the solution for this equation. So that's what I will say. So you try to solve, you write this to, so it's kind of, this is the homogeneous equation, you know, what, by my experience, if this is the homogeneous equation, you don't have to write the augmented one, you just write this because this is always 0. Okay, and then you try to use the RREF and then solve x1, x2, no, sorry, x1, x2, x3, after you get x1, x2, x3, you plug in the x1, x2, x3 into this equation. You automatically get a linear combination. Okay. So that's what I would say for this problem. So I'm not sure if this linear independent or not independent because there is no rule. Okay. So anyway, the method is very easy. You just write this vector as a matrix and try to use the Gaussian elimination, convert it into RREF. If you get non-trivial solution, x1, x2, x3, you just plug in x1, x2 into this equation, into this place. You can write, for example, if x1 is non-zero, you can write a v1 as a linear combination of v2 and v3. It's possible x3 is zero. So it means that x2, no, v2, if x1 is zero, means that this vector doesn't appear in this combination, just them together. Just only have both. Okay. I think this part is about the linear algebra. Okay. So I think I'm done. I didn't miss anything. Okay, one thing is that because there is a problem. So how to expand the determinant by some rows and some columns? Because if you look at the solution, for example, okay, which problem? So if you look at the if you look at the problem, where? Oh. Suddenly I didn't find it. I think okay. Let me wait. So if you look at the problem 4, right? If you look at the problem 4 is in page 3, right? So if you look at the problem 4, you can say the problem is asking you need a, you expand the following determinant along the third row, and then the instructor, write the checkerboard. By my method, you don't have to memorize it, right? For example, you can say if you look at the third row, the first is A13, A31, automatically you know that's positive. A32 is negative. A33 is positive because they add them together is an even number. A34, this is even. You don't have to memorize that. If you don't spend the time to memorize that, use my method. Here, the sign is from the, from this number. Clear? Okay, so I will not take a break because after I finish the talk, you can leave or do the problems by yourself. Okay. Okay. So any question about the linear algebra part? Okay, no questions. So let's look at the second part. Is about the differential equation. So so you have to know how to solve the type of the linear equation. The first type, the type 1 should be like this. Okay, I think we only know one method. Okay, now the problem, we only know this kind of type now is P, T, Y, T, and Q, T, or Y, X. It's the same, right? So the method is fixed. The first one. So let's look at the problems. So let's look at the problem 5. So the problem 5 should be like, you can look at the first problem. This is this, and 4 over t, y t, plus t power to 4 sine t, and y1 is 2. So first, okay, this is the equation. The first step is find the integrating factor. So how? What's that? This is exponential map. Okay, this is p like this. So you get what's this? Clear? So you have to write it in this form. You cannot change the form because you have to write it in the general form. Yt is equal to t power to 4 sine t. So pt, and then you get this is negative and negative 4 ln t. Okay. So what's this? This is exponential map ln t negative 4. So this is 1 over t power to 4. So this is exponential map. Okay, like I said, why do we do this? The goal is after we multiply by the integrating form, the right hand side is a derivative of some function. So you just memorize it. You don't plug in everything into, you don't have to do any computation. Your goal is to multiply by this on both sides. The right hand side should be 1 over t like this, yt derivative equals to your qt sine t multiplied by this. Clear? So you don't have to do computation. You just, after you get this, you multiply by this on both sides. The right hand side is the integrating factor multiplied by yt, and then we have this is sine t. So this is step 2. So, and then step 3, you integrate on both sides, you get 1 over t fourth. Yt is equal to integrate this is cosine t, it should be a negative cosine t plus c. So you simplify, you get yt is t power to 4 c minus cosine t. Okay, final step, step 4, we have the initial data. The initial data is y0 is 1. Is 2, no, y1 is 2. You just plug it into this equation. 2 is y1 is 1 c minus cosine 1. I don't know what's cosine y. You just keep it here. I don't know, right? Anyway, I think I'm right. No mistake. I think no mistake. I think I'm right. C is 2 plus cosine y, and then you plug in this into this. Finally, write the yt is t power 2, 2 plus cosine 1 minus cosine t. Anyway, this is the final solution. Clear? Nobody give me any reaction. Okay. Okay. So let's look at the text. I think there should be a problem like this, Anyway, I hope you can write in this form, step 1, step 2, step 3, because if you made a mistake, the grader know what you know everything. Maybe you don't have enough time, and also if you fail, if you try to argue this problem with the grader, you may say, I know everything, I just don't have enough time. right? We just made a mistake. It's very clear. Okay, so also a problem. What's the problem? Like it's the same. For example, let's look at this problem. This is x over y, and this is 3. You first you have to write in the general form. This is are they the same method? Or sorry, I made a mistake. My copy is wrong. This is the type 1. Okay, I think this is type 1. So let's look at the type 2. So the type 2 is kind of separable. So if, for example, the problem should be like this, dy dx is y over x. So, sorry, made a mistake. Why? Because if I write it in this form, it's 1 over x, y. There, the type 1, the first type is the same. But now y is in the denominator. That's not the same. Here? Okay. So let's look at this. So they are separable type. This is separable variable equation or linear, no, differential equation. For this kind of problem, in general, in the test, the major problem is unlike this. It's he writing this is p y q x. Nobody knows. You just put y together, x y together, and the goal is like the same dy dpy and dx qx. Sorry. Anyway, qx dx. So for example, for this problem, you just put y in one side, x in another side. After you write it in this form, you can't write it in this form. You integrate it. You get ln y plus, sorry, not plus, equal. Is equal or equals half x squared plus c, right? So, and then what we will get? So, and then we can write this is e like this plus c. This is e half x squared, right? Plus e c. You can say this is always positive, right? But this is absolute value. You cannot write y equal to this form. You cannot write in this form, but you can write it in this form. Even though we have a C, but both C are different. This is wrong. You cannot write in this form. You have to write it in this form. But this time, don't ask me why. Okay. If you didn't follow this method, for some case, you cannot solve C. Okay, but for some cases it works. But if you write in my form, in this form, it works well everywhere. Okay, so the major is that you don't know why it's positive and negative because there is a sign problem. But this C can stand if y is positive and negative. It is determined by the initial data. Okay, so for example, we have to determine the C. We know y0 by this problem is 3. For example, for this problem, if you write EC, it's okay. But if you write y0 is negative 3, you use this method, it's wrong. Okay, don't ask me why now. You just follow my method. Okay. So by this, we solve 3 is y0 is e. For example, still you can say, okay, this is step 1. Try to solve this equation. After you get this, you get the step 2. So what's the step 2? Step 2 is try to determine C. Okay. So we get this is this plus C, but this is 1, right? So you get C is 3 over E half. I'm wrong. I think I'm wrong. Maybe. Oh, nobody tells me. I made a mistake. Oh. Why? Like I said, if I made a mistake, please tell me. Otherwise, I waste too much time.
You don't have to go over again because the methods are same.
Okay, okay. I know. I just write in this. And then you solve y0 is 3. And anyway, and then you get the same method. Okay. So they, I maybe the problem, two kinds of problem will be in the test. I'm not sure. Okay. Anyway, so another kind of problem is the third one. This is different one. dy dt is negative y plus 1 like this. Y naught is 7. So for this kind of problem, it's totally different from the previous ones. Okay, so you can say this is a polynomial. The method is the same. You put like in this form and dt. So what we do this part, we use the partial fraction. I think you know this in Calc 1, right? So you can write this is 1 like this minus 5 dy is negative dt. The goal is use a partial fraction for this part. So by partial fraction, if we have y plus a, y plus b in general, for example, there should be ay plus b or cy plus b like this, or just a number, some number say like this. So you can write in y plus a number here, d plus y plus b, a, b, c is known. You have to determine c, d, e like this. So it's kind of for this part, you test us 1 over like this can be written as in this form, sum a plus like this b. So how do we determine a, b? So combine them together. You get this y minus 5 is a y minus 5 plus b y plus 1. And then you get 1 is a y minus 5 plus b y plus 1. Okay. And then you can get what's the a and b, right? So you can say a plus b is y plus b minus 5a is, you can get a plus b is 0, b minus 5a is 1. And then you solve what's ab. You don't have, I think there should be a problem like this in the test. Anyway, perhaps sometimes the instructor, is not that, nice. Give you a quadratic form here. You have to write it in this form by yourself. Here, I'm not sure. Maybe he's writing equation like 6 plus 4y minus 5, kind of like this. You have to first factor it out by yourself. And then you solve a and b. For example, you can solve a, b for this problem. A should be negative like this, right? B should be, I think so. Okay. After you got this, you can say your right hand side is, you get this, your right hand side, it should be and then you integrate it like what I said before. Okay, I will not repeat it again. Here. It's
Yeah.
kind of we have this solve 3 type of equations. I think that's all type of equations. Okay, so this is about the equations, and also there are 3 types of plan the mathematical problem, right? So for that part, I think the first one is about the cooling and heating. For the cooling and heating, it's kind of the method is fixed, right? You consider dy dt, which is k dyt, like that. Oh, sorry, cooling and heating. I think it's very hard to general summarize them, but okay. So first one, okay, I think let me think. How do I present this part? Anyway, so I will not give the details. It's first one is about the cooling and heating problems. Okay. And the second one is about saving interest. The third one is about the brain problems. I will not give you examples by here. So because it's very, you have to get the meaning. I think the only hard part, if just memorize these 3 models. Because if you, for example, maybe next year, I forget the models because I'm not studying the applied math. If you study applied math, you can may remember it, but I cannot memorize. Every time, I have to think it for a while. Okay, you just memorize the models, and then after you memorize the models, the second part is about the solve differential equation. I think I already tell you how to solve this, 3 types of equations. Okay. So that's what I want to say today. I'm done. So if you have any other questions, you can ask me. I will be here. Okay. If you want to leave, do the problems by yourself, of course you can. Okay.
Can we go over a brine problem?
Okay. Okay. So, okay, let's look at the brand problem. Oh. Okay. Where? Where? Which page?
I'm sorry, what did you say?
Which page?
Oh, it should be on the review. I gotta go check. I just knew there was one on the review. I believe it's
7. I got it.
okay.
Okay. Okay. Problem 7. So first you draw a picture like you studied in the bigger class. So this is a brand problem. So it's 800-gallon tanks contains. It's kind of, this is the 400 gallons of water in which is dissolved. This is water. Okay. In which it is dissolved. This salt. Okay. And then the brand contain 4 pounds of salt per gallon. Enter there's something in, right? And also something out. Okay. So how does the water get in? It's kind of permit. We have 7 gallon in, but the 7 gallon water containing 4 pounds salt, right? And also per minute, we have 2 gallon water or brine get out. Yeah. So it's kind of like this. So we assume at the time t, the salt is YT. Okay. So this is the salt. So what's the salt inside? So the salt, of course, when YT is 0, we have this salt because this is the initial data. The problem tells you at the beginning we have so much salt. Okay, and then let's look at YT. So at the time YT, so let's look at this is YT, and at YT plus delta T, how many salt do we have? So we don't know, but we know if we use this minus this, this is the change of salt at delta T, right? Or between delta T time. So let's first look at, the salt. So the first, how many salt get into, wait. How many salt get in? So per minute, we have 7 gallon. The time is delta T, right? This is water get in the tank. But we know per gallon have 3 pounds salt. In delta T time, we have 7 delta T pounds or gallons water get into this tank. But this is a gallon, and then per gallon have 4 pounds. Just multiply by 4. This is the gallon get into the tank at time delta T. And then this is in, and then let's compute the out. So out is complicated. So also delta T, right? And also we know per minute, we have 2 gallon water or brine water, okay, get out of the tank. So this is 2 gallon, this is a gallon, this is the water or brine get out of the tank. But we care about the salt, right? So you have to know per gallon how much salt do we have per gallon water or per gallon brine. So we know this. So this time it's complicated. We have to first know how many salt do we have at this time. So we have salt YT because at time T, right? And then this is the salt. And then how many water do we have or brine? So at the beginning we have 400. So what's the time? We already go through period of time T. So every minute we have 7 in, 2 out. So it's 7 minus 2, and then multiply by T. Okay. And then you multiply by this. It's kind of, this tells you at the time T, we know per gallon water or brine, how many salt do we have per gallon water or brine? And then you use this minus this. And then if you write it in this form, this is y plus delta T minus YT and over delta T. This is 7 multiplied by this minus YT and 400 plus 5T and 2. So, and then you let the T go to infinity, go to 0, and we write the differential equation. So if you look at the solution, the professor doesn't explain this process. Okay, but it's the same. So finally you get a yt is this minus y2y multiplied by this plus 5u, and then you have to know how to, I don't think maybe the instructor will not ask you to solve equations. Otherwise, we don't have enough time. Okay, this is yt. Is it okay?
May I ask a question?
Okay.
So like for the finding the whether if it's like linear independent or not, like what if the reduced echelon form has no solution?
Wait for a moment.